have 1 minus cosine squared times cosecant. And here's what you did before, okay? What you did before is you changed this, don't write this down, but you did 1 minus cosine squared of theta, and then you multiplied that by 1 over sine of theta. You would convert it. And that's not what we're going to try to do today. We're going to try a different way of simplifying these expressions. And anytime you see a 1 and a squared, a light bulb should go off in your brain. You should be like, oh, yay, there's 3 formulas that are really important to me. One is sine squared of theta plus cosine squared of theta is equal to 1. We should also know that 1 plus tangent squared of theta is equal to secant squared of theta. And 1 plus cotangent squared of theta is equal to cosecant squared of theta. So you can see that these formulas have variations in how we write them. So for example, I'm going to make this first one right here. It's important you see this, otherwise you won't have any idea what you're doing. I'm going to take this first formula, and I'm going to make it look like this. Okay, see how this has a 1 minus cosine squared? How can I make that happen with this first formula? So if I subtract the cosine squared over to both sides, I come up with a new formula. The new formula says sine squared of theta is equal to 1 minus cosine squared of theta. Agreed? So the first step to reducing this trigonometric expression is to substitute instead of 1 minus cosine squared, I write sine squared. We multiply that by cosecant. Now this is much more similar to what we covered in the previous days. I can now write this as sine squared theta over 1 times 1 over sine of theta. What will happen? Do both of the sines cancel, or just one of them cancel? Just one of them, and we're left with sine of theta. I might be wondering, well, how do we know all that? Well, if you look at your sheet at number 5 says sine squared plus cosine squared is 1, right? Then look over to the box to the right-hand side. The box on the right-hand side, I've already performed, basically all those operations for you. So you can see sine squared is equal to 1 minus cosine squared. On your sheet, what is cosine squared equal to? 1 minus sine squared. So you can kind of get used to seeing those, and that's where you're going to pull from, okay? So let's try another example. Look at M. Secant squared minus 1. Is that something special on your sheet? Which one would you look at? Number 5, 6, or 7? Let's look at number 6. You see secant squared minus 1 over by number 6? What is secant squared minus 1? Tangent squared. Now, this is like what we've already covered. We can simply change this to terms of sine and cosine. Cosine squared of theta times sine squared of theta over cosine squared of theta. What happens? You're left with how about secant squared of theta minus 1 over sine squared of theta? What is secant squared minus 1? Just what do you get? The tangent squared of theta over sine squared of theta. should I change it to? So I'll multiply by the reciprocal. And what happens? Over cosine squared, is that something special? Secant squared. Hey, Nathaniel. If you look at problem O, we have tangent squared minus tangent squared times sine squared. I think a lot of people want to do that's entirely incorrect right away. Cancel out the tangent squared. So tangent squared minus tangent squared is 0. So 0 times sine squared is 0, so the whole thing is just 0. Okay, that's what we call voodoo math. Okay, doesn't work out. That's totally illegal. You don't want to do that. So you see that we have these squareds, and I'm going to use them to my advantage. But I'm going to show you a little bit different trick. This is kind of the last trick I'm going to show you for the day. I'm going to change the problem a little bit to see if you understand it this way. I have two terms. What do the terms share in common? They both have what? X squared. If I factor out an x squared, what remains in this place? 1 minus, if I factor x squared from here, what remains? Y squared. So, what do these two terms, what do they share in common? They have a tangent squared, correct? I'm going to take it out. So what are you left with here? 1 minus, what are you left with here? Sine squared. Everybody see that? Try to show it with something you're a little bit more familiar with over here. Same type of problem right there. Is 1 minus sine squared something special on your sheet of notes? Cosine squared. Now we have a problem just like we did the past couple days. Let's turn tangent squared into a fraction. What do I have? Sine squared over cosine squared times cosine squared over 1. Cosine squareds cancel, leaving sine squared. Two more. What can we factor out of the next one? Repeat. Let's factor out the sine squared. What are you left with here? Secant squared. What are you left with here? Is secant squared minus 1 something special on your note sheet? Tangent squared. So I have sine squared times tangent squared. Now I can approach the problem just like we did the past couple days. Sine squared over 1 times, what is tangent squared? Sine squared over, does anything cancel? No, it doesn't. So this actually doesn't really help us to rewrite it like this. So I'm not going to do that. This is the simplified form right there. So if you look at number 6 is 1 plus tangent squared is secant squared. let's try Q. What do I factor out? Cosine squared. Well, I'm sorry. So I take out a cosine squared. Yep. So 1 plus tangent squared is secant squared. Now this is just like a problem we did the other day. Cosine squared over 1 times what is secant squared? And I get. I know that this isn't easy, but I want you to know that this is still kind of in the easy section of problems. There are ones that are more difficult that we won't actually get to all of them. We'll get to a few of them, but not all. So, and that's what we'll cover tomorrow. So, I'm gonna write your assignment. Okay, this is your assignment. So this is what I pulled from first semester. Just gonna verify that that's right. 2.1, page 227. Let me just check really quick here. Where's 18? Oh. 22. 5. 33. 34. 40. 45. 48. Yep, I like that assignment a lot.